So in insertion sort, we'll see that what are the main use cases of it, and what is the algorithm of insertion sort, what is the time complexity of insertion sort. An insertion sort of an array works in the way that it partitions the array into two parts. One part is sorted and initially contains just the first element in the array. So basically it divides the array into two parts. When it starts, the first part will have just the first element and the second part contains the remaining element. So understand the difference. Partitions the array into two parts. One part is sorted and initially contains just the first element in the array. The second part contains the remaining element. Okay. So one part is sorted and initially contains just the first element in the array. The second part refers to the remaining elements. The sort inserts one by one the elements in the unsorted part of the array into their proper location within the second part of array. Okay. Let us see an example. So what we have done here, let us see that how it works. So this is a unsorted. So first I will do is that I have created two array. Basically logically, the array is only one. We are logically thinking that there is two parts of the array. So don't think that I have broken the array into two parts. It still remains a single array. Logically, I am assuming that there are two parts of two different array, and that is the way the calculation works. So it is a logical separation, not the actual separation. So there is one array here and one array here. This is called sorted and this is called unsorted. Okay. Now what we do is that we take the first element of the unsorted one and then we try to put it in a right place into the sorted one. Right place means in a sorted order. So what we do is that we take 6 and we check, is 6 larger than 15? No. Then check the previous one. If there is nothing, then put 15 before 6. And for that, what we do is that we do the swapping 6 and 15. Okay. Now now the new sorted array, which is the new sorted array? Is this one. Or let me just do differently. So new sorted array is this one. New unsorted array is this one. Okay. Now in this sorted array we are going to put 10. This is unsorted. What we will do is that we first of all from this one we always take the first element. Whatever it is, doesn't matter. Always take the first element of unsorted array and then try to put it at a proper place in this array. And how do we put it? First go and start comparing with the rightmost. Is this element larger than this? No. Then go to the next one. Is this element larger than this? Yes, it is larger than this. Then what you do is that all the other elements, this one is going to swap with this one and this comes here, this comes here. So that this element will be inserted between after this. So when you move this one after this, these elements go next step. Okay. So the idea is put this one just after this and move this element which is larger than this to one step right side. You can understand this better when I come here. So think about this one. Okay. This is your unsorted array. Okay. And this is your sorted array. How it exactly works. Now I have to put 3 into this one. So what I will do? First I will check, is 3 larger than 15? No. So store 3 into a variable and move 15 one right side. Then compare 3 with 10. Is 10 larger than 3? No. Then move 10 right side. Is 6 larger than 3? No. Then move 6 right side. Is 5 larger than 3? Is 3 larger than 5? No. Then move 5 right side. Once you move everything, there is nothing here, then you move 3 here. And that is what it happens. 3 is gone here and this one moved here. So 15 got moved here, 10 got moved here. See this one. Okay. And that is the way the whole thing got shifted, and this 3 got moved here. Now the new element is 8 and this is here. So again, is 8 larger than 15? No. Then move 15. Is 8 larger than, is 8 larger than 10? No. Then move 10. Is 8 larger than 6? Yes. Now here you can't move 6. What you have to do is that just put 8 next to 6, because this place has become vacant after moving 10 here and 15 here anyway. Okay. So that is the way the basically unsorted array becomes a sorted using insertion sort, because we always makes two division, one array of sorted, one array of unsorted, and from unsorted we take the first element and put it inside this array at a right place. And all of these two partition of array, putting it all are logical. We don't really create two different array objects. In the same array, we keep thinking logically that this part is called another array logic. I will have to put some logic here and some logic here. Again, some logic here and some logic here. So it is the different part of the array where different logic is working up. It is not physically two array broken into or something like that. Now let us look into the runtime analysis for insertion sort. Insertion sort has runtime analysis, as I mentioned, order of n square. The closer an array is to sorted order, the less work an insertion sort does. So if the number of elements move from their exact order is very small, then it will do a lot less work. So depending on how unsorted is the array, it is proportional to that the work will be there, which is good, because in cases where the array is not too much unsorted, it will not have too much of work to do. Now let us see an insertion sort algorithm using animation. So here is the insertion sort. Now what we will do is that we will take 99 and put it here. Now 11. So 11 I have to put inside this one. Okay. So let me just do it little slow so that you can see it. So this is the array, this is the index, and I am going to do insertion sort. So first it will take 1 and it will see that where I can put in this sorted array. So 15 and 1. So what it will do is that it will check, is 1 greater than 15? No. Then it will move 15 one place here and see if there is anything here. There is nothing here, so it is a first position of the array, so it will put 1 here. So first it will move this 15 to here, and it will move this 1 into this position. Okay, that is what it will do. Now if you see here, what happened is I have taken 65 and I have to put it inside this array of sorted array. So what it will do is that it will compare with 28 and put it here. Now 11 is there, he has to put 11 somewhere here. Okay, so think about this 11 array, I have a sorted array, this is my sorted array, okay, and this is my unsorted array. Now what happens here? This is sorted array, this is unsorted array. And now from 11, which is the first element in unsorted array, I want to put it inside this sorted array. So what I will do, I will first compare 11 and check, is 11 greater than 65? No, then move 65 to this location. So this one will go, this one will come here. Then I will compare 11 with 28. Is 11 greater than 28? No. So this one will also move to this place. Is 11 greater than 15? No. Then 15 will also move to this location. Is 11 greater than 8? Yes. Now it is greater than 8. So now you don't move 8, you move 11 at this position. Okay. So now it will become 1, 8, 11, 15, 28 and 65. So that is what this program will do. Let us see that. So when I do a step, it did move 65 because 11 is smaller than 65. 11 is smaller than 28, so it moved 28. 11 is smaller than 15, so it moved 15. 11 is not smaller than 8 this time. 11 is greater than 8. So what it will do? It will not move 8. Instead of that, it will put 11 there. Got it? Now I have to move 1. So it will again compare 1 with 65. Is 1 greater than 65? No. Move 65. Is 1 greater than 28? No. Move 28. Is 1 greater than 15? No. Move 15. So that is the way it will keep moving until I find that we have somebody who is smaller or equal to this one. Now same will happen with 36. Now here 65 is greater than 36 is not greater than 65, so it moved, but 36 is greater than 28. So now 28 it will not move, 36 will come here. Okay? And that is the way it will keep doing for this unsorted array to this sorted array. Put first element of unsorted array into a right position into a sorted array, and that is what is called insertion sort, because we are taking a first element of an unsorted array and inserting inside a sorted array. That's why it is called insertion sort. Okay, so let us run this one. We'll do it, let it keep doing, and this is what insertion sort it will do. If you see that this size is growing and this size is shrinking, this unsorted one I am inserting one by one into this one. All the unsorted one I am inserting into this one by one. And that is the way the array is sorted using insertion sort. Okay.